Okay, let's look at dividing rational expressions. So they work the same way as dividing fractions. So we need to invert and multiply the second expression. And we also really need to make sure that everything is factored. So I'm going to invert first. And I'm going to multiply. Now I look, is it factored? So this is factored. Really, this means x plus 2 twice. This is fine, and this is factored, and this is fine. So we're good. So I can multiply top times top and bottom times bottom. So I have 2x, x plus 2 squared, 3x minus 2, all over 3x minus 2, and x plus 2. So there's no other monomials on the bottom, so I'm left with a 2x still. I have an x minus 2 and 3x minus 2 and a 3x minus 2. I have x plus 2 squared, which means there are two of these brackets, and there's one down here. So this will cancel with one of those, which still leaves me with an x plus 2. So I have 2x. X plus 2 is left when I'm finished reducing. Still need to state restrictions. Restrictions are stated on the denominator. They're stated on the denominator of the original function or anything that is or was a denominator. So we need to be careful with division because it creates new denominators. So there's a denominator here. There's one here, but this was also a denominator. So restrictions also need to be stated on this. So if I start here, I have 3x minus 2 cannot equal 0. So I have x cannot equal 2 over 3. There's my other denominator. X plus 2 cannot equal 0, so x cannot equal minus 2. But this was also a denominator. I've covered the 3x minus 2. It's already here. But I need to also do the 2x. The 2x cannot equal 0 or x cannot equal 0. So there's my final answer. X cannot equal 2/3 minus 2 and 0. Okay, if we look at this next one, we need to invert and multiply. So I have 8x squared minus 50 all over 3x squared, and I'm going to multiply that and invert the other one. I look to see is it factored so that I can multiply top times top and bottom times bottom. It is not factored, so it means I need to factor it. If I look at this first one, there's a common factor of 2, and I'm left with 4x squared minus 25. And on the bottom, I just have a monomial of 3x squared. If I look at the top of this one, I have a common factor of 5, and I'm left with 2x minus 5. This bottom needs to be factored. I'm going to do it over here on the side. So I have 4x squared plus 20x plus 25. So I'm looking for two numbers that I can multiply and add, and I get 10 and 10. There's a common factor of 2x. I'm left with 2x plus 5, plus 5, 2x plus 5, and I have 2x plus 5 times 2x plus 5, which is 2x plus 5 squared. Okay, so this is known as a perfect trinomial square because both brackets are the same and they end up squared at the end. If I look, I'm going to add in 2x plus 5 squared. So now I can multiply top times top and bottom times bottom. But the problem is this isn't factored fully yet. That's a difference of squares. So we need to finish that. So I have 2x minus 5, 2x plus 5, all over 3x squared times 5, 2x minus 5, all over 2x plus 5 squared. Now I can multiply top times top and bottom times bottom. So I have 10, 2x minus 5, 2x plus 5, 2x minus 5. You could make 2x minus 5 squared. That would work too. And this is all over 3x squared, 2x plus 5 squared. So if I look, I have a 10 and I have a 3x squared. They're not going to simplify. So I'll still have 10 and 3x squared. I have 2x minus 5, 2x minus 5, and there isn't any on the bottom. So I'm going to be left with 2x minus 5 squared on top. I have 2 of these and 1 of these. So this will cancel with one of those. Remember, this is squared, which means there are 2 of them. We would write it out twice. So I'm left with 2x plus 5. So now we need to look at restrictions. So I'm going to go back to basically the original question where it's factored and look at what was on the denominator. So 3x squared was on the denominator. So I'm going to do restrictions for that one where x cannot be 0. This one is now on the denominator. So I have 2x plus 5 squared, which really means I have 2x plus 5 cannot equal 0, and x cannot equal negative 5 over 2. This was on the denominator, and so it also has to have a restriction. So I have 2x minus 5 cannot equal 0. So x cannot equal 5 over 2. So now we can state restrictions on the final question. So x cannot be 0 or plus minus 5 over 2.